Ever feel like you're drowning in data?
Oh, absolutely.
Well, today we're diving into a specific type data.
Okay.
One that's all about patterns that unfold over time.
Yeah.
Time series data.
Right.
And you've brought us some really fascinating research about a new way to understand it.
Yeah, this isn't just about spotting whether something is going up or down.
Right.
It's way more nuanced than that.
Okay.
We're talking about time series decomposition.
Hmm.
Imagine being able to take raw data and neatly separate it into its fundamental components.
Okay, so let's unpack that a little bit.
Yeah.
What are these components and why is separating them out so important?
It's like taking that messy beam of light and splitting it with a prism
Right.
to see all the individual colors.
Yeah.
In time series decomposition, you're revealing the long-term trend, the cyclical ups and downs we call seasonality, and whatever's left over, the remainder.
Oh, okay.
Each part tells its own story.
So it's like detective work, right?
Exactly.
You're not just looking at the crime scene as a whole.
Right.
You're searching for fingerprints.
Yeah.
DNA. All the individual clues.
Precisely.
Okay.
Let's say you're analyzing energy consumption data, just like the researchers did in the paper you shared,
Okay.
by isolating the seasonal component.
Right.
You might discover that electricity demand spikes every weekday evening.
Oh, interesting.
That tells you something about human behavior.
Right.
People are getting home from work,
Makes sense.
switching on lights, making dinner.
Yeah, those everyday patterns.
It's fascinating.
But the research that you sent mentioned a specific challenge. What happens when you have multiple seasonal patterns layered on top of each other?
That's where things get really interesting.
Right.
We've talked about daily cycles.
Right.
But imagine trying to make sense of data that has weekly, monthly, even yearly patterns all intertwined.
Wow.
Traditional methods, even the robust ones like STL,
Right.
struggle to untangle these complex, overlapping seasonal patterns accurately.
And that's where this new algorithm comes in, right?
Exactly.
The one we're diving into today.
They used electricity demand data from Victoria, Australia.
Okay.
A perfect example of data with multiple seasonal cycles.
Right.
And you provided this fascinating research paper on a new approach to this very problem.
And that new approach is called MSTL.
Right?
Which stands for Multiple Seasonal Trend Decomposition using LOESS.
Yeah, it's a mouthful.
It is a bit of a mouthful.
But
it's doing some pretty elegant work, I'm guessing, behind the scenes.
it is, yeah, it's doing some really elegant work.
So this MSTL is coming in to save the day when those seasonal patterns get out of hand.
Yeah.
Like a super-powered algorithm.
That's a great way to put it.
Okay.
And what's really clever is that it builds on that existing STL method.
Okay.
That's a well-established technique.
Right.
But MSTL takes it a step further.
So it's like STL got an upgrade.
Exactly.
Okay, tell me a little more about how it actually works.
So imagine STL as making a single pass to separate the data.
Okay.
But MSTL is more meticulous.
Okay.
It applies STL iteratively,
Mm.
like going over a puzzle multiple times
Okay.
to make sure you've got all the pieces fitting together perfectly.
Yeah.
This allows MSTL to tease out even those subtle,
Oh.
interwoven seasonal patterns.
So it's repeating the process, getting more refined each time.
Exactly.
That makes sense, but I imagine it could get kind of complicated.
And it can.
Yeah.
But MSTL has this built-in tool for managing that complexity,
Okay.
something called the S-dot window parameter.
Okay.
Think of it like adjusting the focus on a camera lens.
Okay.
You can capture both the sweeping panorama, the fixed long-term seasonal patterns, and zoom in on the finer details, those seasonal variations that might be evolving over time.
That analogy helps.
Yeah.
So it's flexible, it's thorough,
Right.
but let's be honest.
Yeah.
This is probably some pretty intense math happening in the background.
There is some serious number crunching going on.
Right.
But that's the beauty of MSTL. Okay.
You don't need to be a math whiz to use it.
Right.
The algorithm handles the heavy lifting, so you can focus on what really matters. The insights.
Yeah.
And those insights can be pretty amazing, as I think you'll agree,
Okay.
when we look at how MSTL performed in the researchers' tests.
All right. You've got my attention.
Yeah.
Let's talk about those tests. How did MSTL measure up? All right. So we've got this powerful algorithm, MSTL, ready to tackle those multi-layered seasonal patterns.
Right.
What kind of obstacle course did the researchers set up for it?
They really put MSTL through its paces,
Okay.
testing it on both simulated data,
Right.
where they knew exactly what the true patterns were,
Okay.
and on real-world electricity data from Victoria, Australia.
So they ran it through the real-world ringer using that complex data we talked about earlier.
How did they make sure the test was fair, though?
They used a clever technique called moving block bootstrap on the real-world data.
Oh, yeah.
Imagine taking that data set and chopping it into blocks,
Okay.
then shuffling those blocks around to create different variations.
Mm-hmm.
It's like creating a whole bunch of alternate realities
Okay.
from that same data to see how well MSTL
Yes.
adapts.
Like a stress test for the algorithm.
Exactly.
Making sure it can handle any curveball you throw at it.
Right.
And did MSTL pass?
MSTL passed with flying colors.
Okay.
They compared MSTL's performance to other techniques like STR,
Right.
another decomposition method,
Okay.
and even popular forecasting models like TDATS and Profit.
Okay.
And across the board,
Yeah.
MSTL consistently came out on top.
Okay, impressive. But what does outperformed actually look like? What kind of improvements are we talking about here?
Well, in the paper, they use a metric called RMSE,
Okay.
root mean squared error,
Okay.
to measure how accurate the predictions are.
Right.
It basically tells you how far off the predictions are from what actually happened,
Okay.
and lower is better.
So a lower RMSE score means that MSTL is getting closer to reality
Exactly.
than these other methods.
Yes, and MSTL was racking up some seriously low RMSE values,
Oh, wow.
especially when it came to capturing those intricate seasonal patterns
Okay.
in both the simulated and real-world data.
That's pretty compelling.
Yeah.
But beyond accuracy, wasn't there something about MSTL being faster too?
Yes,
For people working with mountains of data, that could be a game changer.
absolutely.
Yeah.
In data analysis, time is often a luxury
Right,
that
yeah.
you don't have. Yeah.
The researchers actually timed how long each method took,
Okay.
and MSTL was significantly faster than the competition.
Wow.
That efficiency is a huge win, especially when you're dealing with massive data sets.
So we've established that MSTL is powerful, accurate, and efficient.
Right.
It's like the trifecta of time series analysis.
It is.
But let's shift gears for a second.
Okay.
This is all very impressive from a technical standpoint.
Sure.
But how does it actually affect, the rest of us?
Right.
Why should someone who isn't a data scientist care about a new algorithm with a complicated name?
That's the million-dollar question, isn't it?
Yeah.
It's about bridging the gap from theory to real-world impact.
Right.
Think about it this way. MSTL can help us unlock insights that were previously hidden in plain sight.
And those insights can touch so many aspects of our lives.
Give me some examples.
Sure.
What kind of real-world applications are we talking about here?
Well, let's start with something we all rely on. Energy.
Correct.
Imagine more accurate energy demand forecasting thanks to MSTL.
Okay.
That means energy providers can optimize resource allocation,
Right.
reduce waste,
Right.
and create a more stable and sustainable power grid.
So, fewer blackouts, lower costs.
Exactly.
That's something we can all get behind.
Right.
What else?
Think about the way we shop,
Okay.
the things we watch,
Yeah.
the information we consume online.
Right.
MSTL can help businesses understand consumer behavior with a whole new level of detail.
So you're talking about personalized recommendations that are actually helpful.
Exactly.
Products and services that anticipate our needs,
That-
that kind of thing.
And it goes beyond just marketing.
Okay.
Imagine healthcare professionals using MSTL to analyze patient data,
Okay.
leading to earlier disease detection,
Wow.
personalized treatment plans,
Okay.
and potentially even preventing health issues before they arise.
That's incredible.
It is pretty amazing.
It seems like MSTL has the potential to touch so many different fields.
It really does.
Yeah.
And let's not forget about things like fraud prevention and cybersecurity.
Right.
MSTL's ability to spot anomalies.
Okay.
Those data points that deviate from the norm
Right.
could be invaluable for detecting suspicious activity
Okay.
and preventing potentially catastrophic events.
So as we wrap up this deep dive into the world of MSTL,
Yeah.
it's clear that this algorithm isn't just a technical marvel. It has the potential to make a real